Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. For this lesson, I want to discuss on the revision of the previous 13 weeks lecture. So, in the previous 13-week lectures, we have um, we have discussed on the importance of forecasting, okay? And then we have discussed on the component factors of the time series model involving T as Ci. T is a trend, S is a seasonal, C is a cyclical, and I is a irregular or random. Then we have learned about the moving averages, exponential smoothing, least squares trend fitting and forecasting, the linear and linear quadratic and exponential models. So all these things will be covered in the examination or the final assessment. And then on top of that, we have the House method for trending, fitting, and forecasting. Then I have teach you the autoregressive models, or AR model. So we have AR model, AR models, okay. And then we have a method of how to choose or how to identify AR model from the raw data. So normally we use ACF or autocorrelation functions, ACF, and then we have also used the PACF, a partial autocorrelation function. Okay? And then there is one more method that will be discussed in this lecture. It's known as what you call unit roots, the unit root. So you can also use unit root to determine the appropriate model for the from the um, uh, from the what you call the uh, autoregression model. Is no, sorry, it's not unit roots. Unit root is used to there's one more method. Unit root is used for to determine whether the data is stationary stationary or uh, invertibility. Okay, this will be discussed in this lecture. Okay, and then so we have several models. Is AR model, we have MA model, we have ARMA model, and ARIMA model, and then stationarity. You can use there is a few methods by looking at the mean, by looking at the mean, and then also we have learned how to decide whether the data is stationary or not by looking at the variance. Okay, variance, and then one more method is what I call the unit root method. Unit root method, unit roots. So to find the unit roots. Okay, unit roots. Okay, and then we also have learned about lag operator or backshift operator. Okay, from the equation to find the unit roots, you can use the lag operator equations. Then from there you can find the unit root. And I will be discussing in this lecture. Okay. So far we have learned all these things, and these things will be covered in the final assessment or final examination. So please focus on this all these things that this will be covered in the final examination. Now, just for the revision, okay, for the revision. So let's say I want to determine the model here. I want to determine the model by I want to determine the stationarity. Okay, so let's say we go to the stationarity and different things. So in order to find whether the data is stationary time series or the series stationary times or stationary time series, we can check the behavior of the data. Okay? From that, we can determine whether the data is stationary or not stationary. Okay. So this is just a revision. This thing I have discussed in our previous lecture. So just for the revision. So let's say I have this kind of graph here. So by looking at this graph, so you can determine whether the data is stationary or non-stationary. So this graph. So in order to determine the data is stationary or non-stationary, we have to check the mean and the variance. Okay, the mean and the variance, mean and the variance. Okay. So look at the first graph here. The first graph here, we can see that this graph, okay, the first graph here for graph A here, okay. So now we can decide here, okay, if I draw a line here. Now I draw a line here. The line here is if I draw a line here, okay, okay, draw a line here. I draw a line here. Now let's say I draw a line here. Uh, this is the line here. This is an upward trend. So here is upward trend. So we need to say if you have an upward trend here, this is not the mean is not constant. Eh? So the trend here, the mean here is this trend is an upward trend. So stationarity cannot be, you cannot have a upward trend. So for this case, this is not a stationarity data. This is not a stationary data. Now looking at this one, the graph C. So graph C, I have a trend here. This trend, then we have this line and this trend. So we have this way downwards, and then we have upward trend, then we have downward trend. This also we cannot consider as a stationarity because of we have a trend line here. And for this case, E, you have the downward trend. This also cannot be considered as a stationarity. Okay. Then after that we have okay. Then what about this one? This one, F, you have a trend line here, the trend line here, and the trend line here. This also cannot be considered as a stationarity. What about I? I here, you have the mean here, the trend line here is outwards, so this cannot be considered as a stationarity. So what about this trend, this one, this we have here, this graph, we have a big constant here, a little bit constant here. The trend line is a constant trend line. This can be considered as a stationarity. Also this one also can be considered because of the mean here is a flat line here. This also can be considered as a stationarity, and this also can be considered as a stationarity. Okay, by looking at the mean here, so graph D, G, and H can be considered as stationarity, and also this one can be because of you have a trend line here. These three graphs can be considered, and this can be considered as a stationarity. Okay, so B B, D, G, and H can be considered as a stationarity graph because of we have the constant mean here. So we have a constant mean BDG and H can be considered as a stationarity because of we have a constant mean. But okay, so there is one more criteria you have to check here. We have to check the what I call the variance. So we have to check the variance. Just now we check the mean, and then so we need to check the variance. Okay. Now for this case, for this case, okay. So D here. So we can see that the data here is a little bit fluctuation. Okay. So there is a fluctuation here. So it goes down and goes up, it goes down, goes up, goes down, goes up there. So here the data is the variance here is quite is not consistent here. It's not consistent variance. This is we consider as a small variance here, this part. But in this case, this is a very large variance, okay? And here is very large variance. And this one also a large variant here. This cannot be considered as a stationary because of we have a inconsistent variance, so cannot be considered as stationarity. What about this one? This one, okay. This the mean here is quite flat here. The mean is quite flat here, but the variance is quite the variance is inconsistent here. It's a variance here. Now the variance is consistent. It's a very high variance, and here is very high variance. So this also cannot be considered as a stationarity. What about this one? This one, the variance here is quite not flat, but when come to this part, it goes up here. The variance goes up here. This also cannot be considered as a stationarity. And last one, okay, last one, this one, okay, this one can be this one. The mean here the mean here is a bit consistent, and the variance here is a little bit it's also a consistent variance. There is no fluctuation except this one, except that one. So this can be considered as a stationary data. So we have a constant variance and a constant mean except one bar here. So this can be considered as a stationary. So from this, I have two 9 graph here. The only graph can be considered as a stationary data, or stationary times 3 is a graph B. So these are how we decide the stationary based on the graph here. Okay. Okay. Now the next part is this one we have discussed already. When you have the data, you can decide whether your data your time series ARIMA, AR model, MA model, or ARMA model by looking at the ACF and PACF function. Okay, now for the ACF function, if the data is or the graph is a tail off, okay, ACF graph is tail off, then we can consider as a um, the data is the model is a AR model. Now for the MA model, if the PACF is tail off or follows an exponential distribution, eh, is a pattern or damped exponential distribution, then we can consider as a MA model. Now, for the mixed ARMA model, okay, ARMA model, so the graph here, the ACF and PACF is a exponential or damped exponential. So for this one, for the first one, okay, so we can if I have a graph like this, For this one, for the first one, so this one, if I have a graph like this, so I refer to this one, the first one, okay, the first one. Now I have looking at the ACF function, ACF graph, okay. If I have like this, okay, the graph like this, it goes exponentially, okay, it goes exponentially. This is a autocorrelation. This is a autocorrelation. Here is a time period, time. Okay. So if it goes exponentially here, okay, okay, exponentially here, this can be considered, and then this is ACF. Then for your PACF, it has a spike here. Let's say I have one, then goes down here. Okay. Then this can be considered as a Ar model. And for this case, we have only one spike here, one spike. Then this is a Ar1 model. Okay. And for this case, for MA model, now if your ACF graph, you have a spike. Let's say I have two spikes here. Then the rest is still off. Okay. Then let's say my PACF is exponential. PACF graph is exponential. Then exponentially. So exponential, just like that. Then this can be considered as a MA because of you have two spikes here. This is considered as a MA2. Now, if we have ARMA model, so for the ARMA model, so we have both ACF, we have exponential, and PACF also, the graph is exponential, them exponential, both of them exponential. Then this can be considered as a ARMA model. ARMA model. Okay, these are how we decide to choose one model in the time series. Okay. Now, the next part, to find the let's say the next part is I want to discuss that is on how to decide the model based on ACF and PACF. Now, the other part is I want to show you how to find the stationarity by using what you call the looking the stationarity. I want to find the stationarity. Okay, stationarity. Stationarity by using what you call the unit root method. Unit root. Okay, stationarity by using unit root. Okay. Now, just now we can to decide stationarity. Just now, you can either use the what I call the mean and variance. If we have to have a constant mean and constant variance, so zero mean or constant variance. So to find the other way to find to decide on the stationarity, you can use the unit roots method. So unit root, to find the unit root, we need to have the equation here. So let's say this is an equation for what you call for the time series model, and by looking at this equation, yt is a time, y is a time, we have this one, yt is equal to 0.5 yt minus 1 plus by epsilon t, this is considered as a Ar1 model because of the current data depend on the previous data. Okay, so these are Ar model. Okay, these are Ar model. Ar, these are Ar model. So these are Ar model. So these are Ar model. Okay, Ar or Ar1 because of the current data depend on the previous data Ar1 model. So, and then if you look at this one, the second model, this is known as a Ar2 model. It's a Ar2 model because of the current data. These are Ar2 model because of the current data depend on uh, the, uh, the two previous data. Current data depend on yt minus 1 and yt minus 2. And this is considered as a AT or epsilon t. Sometimes they put AT, sometimes we can write as like epsilon t refer to an error. This one is Ar2 model, Ar1, the top one is Ar1 and Ar2. So how to decide, how to determine, how to decide whether this one is a stationarity or non-stationarity. So to decide here, you can use the unit root method. And before we can use the unit root method, we have to know how to find the lag operator. So this lag operator I discussed in the previous lecture. Lag operator, or what we call the, or it's also known as a backshift operator. Backshift operator. So we have to convert, how we have to change the equation here to lag operator and backshift. The equation is just simple here. So for this one, you can change to lag operator as a this equation become yt, here is y sub t equal to 0.5 y sub t minus 1 plus by x on t, and then this can be written as this can be written as this. For the lag operator, this can be written as, so you can put here as a yt, so implies yt minus by 0.5 yt minus 1 equal to x log t, and here become the lag operator here become L1 minus by 0.5 L raised 1 equal to x log t. So we just solve this part because of this is a why is known as a lag operator. So this one, so let's say I put here is this thing is equal to L. This part is known as a function of theta L, for example. So theta L is equal to 1 minus by 0.5 L. Now from here, let's say I change here theta. So let's say I have here theta. So here you can find here. So L here, if I put here is equal to 0 here, so L is equal to negative 0.5, L is equal to negative 1. In other words, negative 0.5 L is equal to 1. Or in other words, L is equal to negative 1 over negative 0.5 is equal to 1 over half is equal to 2. So the L here is equal to 2. And if the absolute value of L, absolute value of F is greater than 1, then the model is said to be, the data is, or times the data is a stationarity. Now, if L, now for this case, L is the absolute value of L is greater than 1 or equal to 2, so the model is stationarity. Now, if absolute value of L is less than 1 or L is equal to 1, then this is a non-stationarity. So the absolute value L must be greater than 1. For this case, the absolute value of L is greater than 1, or in other words, equal to 2. So it's considered as a stationarity. Okay, stationarity. What about Ar2 model? So looking at this Ar2 model, so the model here is given as yt is equal to yt. So before we can solve this one, we have to change to the in term of lag operator. This is an Ar2 model. So here you can write like this: y sub t minus by 1.097 yt minus 1 plus by 0.97 yt minus 2 equal to epsilon t. So this can be written as yt 1 minus by, or you can put here, what you call, you can write like this. So you can change to the lag operator here. You can write in terms of lag operator here. Here become this thing. If you write in terms of lag operator, this thing if you write in terms of lag operator become. So I put here L, okay, 1 minus by 1.097 L raised 1 plus by 0.97 L raised 2 equal to epsilon t. These are what I call the in terms of, we convert this equation in terms of the lag operator. Okay. So to find the unit roots here, to find the unit root, you need to find the value of L here, the equation of L here. Okay. So this part you need to solve this one, okay, to find the root of L here. So you can apply this formula. The L here, you can, the root of L here, or in other words, I can put here is a theta L. Okay, theta L is equal to E epsilon T. So I need to find the roots of L here. Okay, the roots of L here. So let's say I put here theta L. I put here 1, theta L is 1 minus by 1.097 L plus by 0.97 L raised to. Let's say I put here equal to 0. So I want to solve this one. I want to find L here. Okay. To find L here, just now is it is a single L. Here is a what we call the polynomial function or quadratic function. So you need to find L here. Now you can apply a formula of a negative b plus minus by square root of b squared minus by 4ac over 2a to solve the function here. So this can be considered as, this is considered as A, here is considered as a B, and this is a C. So we know that our A here is equal to 0.97 and B is equal to 1.097, negative 1.097, and C is equal to 1. To find L here, you can apply this formula. So by applying this formula, we'll have our L is equal to negative B, or negative 1.097 is 1.097, and plus and minus B square is negative 1.097 square plus by 4 AC sorry, minus minus by minus by 4AC. 4AC is 4 multiplied by 1 because of C is equal to 1, 4 multiplied by 1, and then multiplied by, say, 4 multiplied by, uh, so your, this one is 4 multiplied by, your A is 0.97, 0.97, 4 multiplied by, 4 multiplied by 0.97, then multiply by 1. Divide by, the whole thing here divide by 2A. 2 multiplied by 0.97. To find this one, the what you call the unit root here, you can refer to additional max MOOC, how to factorize. So this is more on how to factorize this function. This is the general formula for factorization. So the general formula for factorization is this. So this let's say I have my function. Let's say I have ax squared plus by bx plus by c. So the general formula for factorization, x is equal to eh, uh, plus minus. So x is equal to negative b. We have 2x here plus and minus square root of b squared minus by 4ac over 2a. This you can refer to the in mathematics how we use this formula to find the factor of to factorize this function. So for this case, you have to refer to your leg operator here. So the leg operator here. So I repeat again the leg operator here. So to find the leg operator, you can put like this: yt minus by 0, 1.097 yt minus 2 minus 1 plus by 0.96 yt minus 2 equal to epsilon t. So we just focus on this one. So the leg operator here become L 1 minus by 1.097 L plus by 0.97 L raised to. So we try to factorize this function. So just now we have, now if you factorize that function, so the answer here is, I give you the answer here is, so after factorization, so the answer here I have L here, my L here is equal to the L, my L1, so I have 2L, L1 equal to 0.57 plus by 0.84. So I just put I here, okay. Then L2 is equal to, if you solve that by using that formula 0.57, B squared is 0. This is B squared, isn't it? B squared. B squared. In other words, 0. Negative, sorry, B squared. Okay. B squared is negative 1.097 squared over 2A. This is over 2A. So this is B squared over 2A. You get 0.597. And this one is 0.84 is, then you have minus here 0.84 I. This is from, this value is from square root of B squared minus by 4AC over 2A. This is 0.84. So I just pick up these two values, 0.57 here and 0.84. I plug A into this formula. The absolute value of L for 1 and 2 equal to square root of, so you can apply this formula. The first factor here, let's say this is a A here, capital A, and this is a capital B. Okay, so A squared plus by B squared, the absolute value of L12 is equal to A squared plus B squared. This must be greater than 1. must be greater than 1. Okay. If this thing is greater than 1, so if we solve this one, 0.57 squared plus by 0.84 squared, you will get the value here is equal to 1.015, which is greater than 1. Then if this is greater than 1, this function can be considered as a stationary function. So it meets the criteria of stationarity. So the second function here, can be considered as a stationarity function. This can be considered as the Ar2 here can be considered as a stationary. Okay, these are stationary, 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 and this also can be considered as stationary because of our absolute value of L here, 1, 2, because of we have 2 factor here greater than 1. This also your L absolute value of L here is greater than 1. So if the value is less than 1 or equal to 1, then cannot be considered as a stationary data. This is how we use a unit rule to solve to determine whether the data is stationary or not stationary. Now, the last part here, I want to discuss on the what you call the invertibility. The invertibility is a concept where invertibility refers to what you call the invertibility refers to the fact that the moving average models, okay, can be written as autoregressive model. The moving average model can be written as an autoregressive model. So then it becomes considered as a invertibility. So how to determine the data is invertibility or non-invertibility? We have to apply the what you call the unit roots method. Okay, unit roots method. So let's say I go to one example here. Okay, I go to one example here. Let's say I want to find. I have this function here. This is the what I call the if you look at this time series, this data, this equation, this is considered as a ARMA 1 1, isn't it? This is the ARMA 1 1 because you have yt minus 1 here and epsilon t minus 1. So this is a ARMA 1 1. So this model is a ARMA model 1 1. So ARMA 1 1. I want to show you how to find the invertibility. So these are ARMA 1 1 because of we have 1t minus yt sub 1 minus 1 and epsilon t minus 1. So these are ARMA 1 1. So I want to check first. I want to check for stationarity. Then I want to check for invertibility. So the thing here to confirm or to decide whether the time series is stationary or invertible, you have to find the absolute value of L here. If greater than 1, then consider as a stationary. Now, if less than 1 or equal to 1, this cannot be considered as stationary. So let's see, we solve the stationary part first. So yt here, by considering yt here, we have yt equal to yt minus 1. I can put as a yt minus 1. These are AR1 equal to 1 over 4, or you can put like this. You can write like this. You can put epsilon t first, epsilon t plus by 1 over 4 epsilon t minus 1. This is a MA model, and here is a AR model. This is AR1, and this is a MA1, and the combination here is a ARMA 1. So for this case, the lag operator for AR1 here is equal to, so you can write here as a L1 minus by L raised 1. Okay. So if you solve this one, if you solve this part, okay, so we put here, so this is equal to theta L, for example. Okay, so if you solve, you put here as equal to 0 here. So 1 minus by L is equal to 0. So in other words, L is equal to 1. So if L is equal to 1, this cannot be considered as a stationary data. Okay. So the process here, the process here is not a stationary. So this one is not a stationary. It's non-stationary. See, non-stationary. Because of our lag operator here, so the what I call the unit root here is equal to 1. By definition, if the unit root is equal to 1 here, it cannot be considered as a stationary. This is a non-stationary. Okay. Now for the second one, I want to check. This also can be, if you want to have a stationary, we need to have the AR1 must be the unit root here must be greater than 1, and MA also must be greater than, the unit root here must be greater than 1. If either one less than 1 equal to 0, then this cannot be considered as a stationary. Both must greater than 1. If one of them is less than 1 or equal to 1, then the data here cannot be considered as a stationary, or is considered as a non-stationary data. Okay. So the second part, I want to check for invertible. Invertible, we have to refer to the MA model. So for this case, your MA model is, this is your MA model. This is only the MA model here. So your MA1 here, MA1 can be written as epsilon T plus by 1 over 4 epsilon T minus 1. Then in terms of lag operator here, it can be written as, so let's say I put here as a B, instead of L, I change to B, the same thing also, B 1 plus by 1 over 4 B raised 1. Isn't it? This is a lag operator or backshift operator. So instead of using L, I use B. B 1 plus by 1 over 4 B to the power of 1. This is a lag operator. So let's say I put here B theta here is equal to 0. So in other words, 1 plus by 1 over 4b is equal to 0. So b is equal to 1 over 4b is equal to negative 1. In other words, b is equal to negative 4. So the condition of invertible is the absolute value of L or absolute value of B backshift must be greater than 1. So for this case, your absolute value of B is equal to absolute value of negative 4. In other words, this is equal to 4 is greater than 1. Then this data is considered as an invertible. Invertible. The data here is considered as invertible. So these are how we use the unit roots to decide on invertible and stationary. Okay, so you can apply, you can use whatever data here, you can use whatever model here. By looking the model here, you have to convert to the what you call the lag operator or shift operator, back shift operator, to find the unit roots, and from there you can decide whether the what you call the model is stationary or non-stationary. You can you can either have the what I call simple model and linear model or polynomial model. Polynomial model is quite complicated. Okay, For example, just now we have a polynomial model. For this case, we have a this what I call it polynomial model. It's quite complicated. You have to use you have to factorize this one. This one is a quadratic. It's quite simple. If you have power of 3, for example, you have Ar3 model is quite complicated. But our discussion is we limit our discussion into Ar2, Ar1, and Ar2 model, or MA1 and MA2 model, because of for the Ar3 model is quite complicated to find to factorize the functions. So we limit our discussion on Ar1 and Ar2, and then MA1 and MA2. Because of for Ar3 model, we need to study a certain method to factorize the function. So I limit my discussion on. So there is a method of there is a few steps to find factor on R3. For our purpose here, we just focus on R1 and R2 and MA1 and MA2. So from here you can check. So in conclusion, so to find the stationary, in conclusion, to find the stationary, you can also use, the first method is by looking at the graph, by looking at the mean, and what I call the variance. The mean and variance must be constant, constant mean and variance. So to decide on stationary, stationary time series, the mean and variance by looking at the graph, looking by looking at the graph. Okay. Or you can use the unit roots method. Unit roots method. Now, for the unit root method, for the ER model, and MA model, we need to have the lag operator here, the factor of lag operator, the absolute value of lag here must greater or equal to 1. Also, for MA, the L here must be greater or equal to 1. So, if we have ARMA model, both of them L, absolute value S must be greater than 1, and then absolute value of B must be greater than 1. Then it confirms a stationary time series. Okay, for the unit roots, unit root method. Okay. Now, for the to invertibility. So for the invertibility, I have to check the MA model. So for the MA model, it to be invertible if my B here, absolute value of B, it must be greater than 1. Okay, so then it's considered as a invertible. Okay, now this is a case of a linear regression, a linear line. But if you have the quadratic, you need to use for the quadratic equation, or quadratic lag operator, polynomial lag operator. So you need to find the factorize it by using this formula: negative b plus minus by b squared minus 4ac over 2a, provided if you have a solution here. Let's say I have a solution here, L is equal to A plus by BI, then the other one L1, L2 is equal to A minus by BI. So the condition here is the absolute value of L1 and 2 is equal to square root of A squared plus by B squared must be greater than 1. Then it can be considered as a stationary time series. Okay. Okay, I think that's all for this lecture. So I have teach you. I want to repeat again for the final assessment. Okay, the final assessment. The I will discuss on the question is on more on moving averages, exponential smoothing, least squares forecasting, quadratic exponential model, Horst-Wheaton model. Okay. Then then we want to decide on the model by using ACF and PACF. Okay. And then you have to know how to determine the stationary and invertibility by using the unit roots that we have discussed just now. And the rest is the last one is on differencing, on the differencing. So differencing is also quite important because of in ARIMA model. So ARIMA model, so we need to do a differencing, isn't it? So we need to do a differencing for the ARIMA model. So the concept of differencing, so you have to know how to solve the equation or the time series by using a differencing. So differencing, differencing. So there's a differencing, ARIMA differencing. So you need to say this lecture or this discussion have given you on the previous lecture. So basically, these are all the things that will be covered in the final assessment. I think that's all for today. Hope you can do, you can solve, the, you can do, you can prepare for the what you call the final assessment, by looking at this, by focusing for focusing on this um, the thing that I discussed just now, this all this part, because of the question is based on what we have learned in our what you call the lecture. So the I have given you uh, the assignment and test, then I will give you a final assignment tomorrow. Okay, final assignment tomorrow, the last assignment tomorrow. So hope you can do it in 1 week time before the final assessment. That's all. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.